Okay, 2.4, the cosine law. So we're going to use the cosine law to help us solve some triangles. And so in this lesson, the cosine law formula you might remember from your previous math course looks like this. So it's going to be, in your notes, it might have been written small, so let's write it bigger. So a squared equals b squared plus c squared minus 2bc cosine a. So it looks something like the Pythagorean theorem, but then there's like a little bit of an adjustment to it, okay, with the 2bc cosine a. If you're trying, that was if you're trying to find side A. If you're trying to find side B, you can just rearrange the formula a little bit. So b squared equals a squared plus c squared minus 2ac cosine of angle B, okay? And if you're trying to find side C, it would be c squared equals a squared plus b squared minus 2ab cosine of angle C, okay? You can also rearrange the formula to find angles. So if you're finding angle A in a triangle, it would be cosine of angle A equals b squared plus c squared minus a squared over 2 times bc. Okay, if you're finding angle B, similarly, cosine of angle B would be a squared plus c squared minus b squared over 2 ac. And if you're finding angle C, the formula would be cosine of C equals a squared plus b squared minus c squared over 2bc. So you have 6 formulas. All of these are cosine law. And these formulas talk about finding either a different side, A, B, or C, or angle A, angle B, angle C. Okay? A couple of important things is if you're trying to find the side length, remember to take the square root, okay, the square root of to get the side length, right? Because you're given a squared, b squared, or c squared, you're solving the entire right side. Whatever number you get on the right side, you have to take the square root to find the side length. And if you're finding the angle, remember, you're going to take the inverse to get the degree of the angle, right? So whatever you calculate for cosine A and cosine B and cosine C, everything on the right side gives you a number, and then you have to find the inverse of that number to find the angle. Okay, so the cosine law is useful in cases where you know two sides of a triangle and the in-between angle, okay? Or if you know all 3 sides of a triangle, right? So that is kind of diagrams that look like this. So I have a triangle, I know a side, I know a side, and I know the angle in between. And then maybe I'm finding the opposite side there, right? Or maybe I know I have a triangle where I know all 3 sides, and perhaps I'm finding an angle. And that's where the cosine law is very useful. And the cosine law would be used instead of the sine law. Okay. So how do we use the cosine law to find to solve our triangles? Well, number 1, we identify known sides and angles in the triangle. Okay, you'll need to know at least 2 side lengths and the measure of the angle between in order to use the cosine law. Okay, and that was what I was supposed to draw here. So let's put that triangle there. Okay, and I can use the cosine law to find measures of unknown sides and angles. If I know the lengths of 2 sides and the measure of the angle between, I can use the cosine law to find the length of the 3rd side. Okay. Let me just fix something. So this was actually supposed to be here. The 3rd side is that x, and if I'm looking for an angle, that diagram was this one. So I'll go here. Okay. So let's, we check your answers, of course, right? So check your answers to make sure they are reasonable and consistent. And we're going to do this with an example to show you how we can apply the cosine law. So here we are. Determine the length of each indicated side to the nearest unit. Okay, so as before, we usually should label our triangle. So if I have side C on the left, I'm going to label its opposite angle C. Okay, and 38 and 35, I can arbitrarily choose which letter to put. So if I put 38 for A and 35 would be B, just make sure you label the corresponding angles appropriately. So opposite of side A will be angle A down here, and opposite of side B will be angle B up here. Okay. And now if I'm looking to use the cosine law, I'm going to be finding side C. So I will write this as C squared equals A squared plus B squared minus 2 times AB times cosine of angle C. Okay, so you write down the appropriate cosine law, and then you plug in the numbers. So for A, I'm going to substitute 38, so 38 squared, plus for B, I'm going to substitute 35 squared, minus 2 times A, which is 38, times B, which is 35, times the cosine of angle 49 degrees. Okay, and then so we take our calculator and we calculate. So make sure you follow along as you do this on your calculators as well, right? So if I do 38 squared plus 35 squared, we will get 2,669 minus 2 times 38 times 35. So let's do that. And that's going to be 2660. And don't forget that's multiplied by cosine 49, okay? And now here's where students make a common mistake where they subtract these two numbers. When you're supposed to multiply these two numbers, okay? So if I do 2660 times cosine of 49 on your calculator, and make sure your calculator is in degree mode, and then I'm going to get 1745. So 2669 minus 1745. I can round to one. Well, I'll round it to the nearest whole number here. Well, actually, no, let's not. Let's do a decimal place, so 0.1. Okay, so 2669 take away 1745.1 gives us 923.9. And remember, that's C squared. So if I want C, I'll take the square root of that number. Okay, so the square root of that number is 30.39. So C is equal to 30.4. Let's round up to 0.4, and that's going to be meters. And so there's my answer for C, and that's using the cosine law. Okay, let's look at another one. What if your letters change, right? So if we're looking for side D, I could write this as D squared. Recognize that you have a side here and another side here, and the angle between them. Okay, so this is an SAS triangle. And if you really look carefully at the cosine law, it follows a very familiar pattern that repeats itself as you do all these problems over and over again, right? So I'd start with the first side squared, 5.5 squared, add the 8.2 squared, and subtract 2 times each of those side lengths, 5.5 times 8.2 times the cosine of the angle between, 108, okay? Now, if that's hard to see, then you can go back and relabel your triangle ABC and then follow the formulas then, okay? So then you just kind of evaluate, simplify, evaluate all this. So here we're going to take 5.5 and square it. So 5.5 squared plus 8.2 squared gives us 97.49. Take away 2 times 5.5 times 8.2 times cosine of 108. And that's going to be a negative number, because remember, cosine of an obtuse angle is negative, right? So negative 27.87. And then, so 97.49, take away a negative number means you're going to add double negatives, right? So that's going to be 97.49 plus 27.87. Remember, if you're not getting these numbers, you have to double check your calculators to make sure you are in degree mode. And so here we have 125.36, that's D squared, And so if I want d, I take the square root of 125.36. And so d is going to be 11.2 if I round that to one decimal place. And I'm going to say that's in centimeters. Don't forget your units. Okay. You're going to be tasked with trying the you-try questions, and we can take those up when we return to class. Okay. Looking at another example, example 2. What if we're asked to find the angle, right? So here we have, we have 65 kilometers, 50 kilometers, and 39 kilometers. We have three sides of a triangle, SSS. So the cosine law applies here. Okay. And so it might be helpful to label, right? If I labeled the angle theta A, right? And then side B, across from A will be side little a. Okay, and then I'll make 65B, and then across from B will be angle B, and I'll make 39C, and across from 39 will be angle C. Okay, so if I'm finding angle A, we can go back to our formulas, right? And we see here we have a formula for angle A, right? Cosine of A equals B squared plus C squared minus A squared over 2BC, right? I can take that formula, and let's bring that down here into our page. Okay, so there's our formula, and we're just gonna use that formula to help us solve our problem. Okay, so plugging in the values that we have, we can say here cosine of angle A equals B squared, which is 65 squared, plus C squared, which is 39 squared, minus A squared, which is 50 squared, divided by 2 times B times C. So 2 times 65 times 39. Okay, and then we calculate. Okay, so if we calculate this, we're going to have 65 squared plus 39 squared minus 50 squared. Also, the numerator is going to be 30,246 when I simplify that, and the bottom is going to be 2 times 65 times 39, which is 5,070, right? And that's equal to cosine A on the left. Continuing on to the next line, cosine of A equals 32. So let's do that, 3246 divided by 5070. And that gives us 0.6402 if I take it to 4 decimal places. And remember, that's not an angle. If I want the angle, I have to take the inverse. And the inverse of what? It's going to be the cosine, right? Cos inverse of 0.6402. And that's equal to, let's just make sure your calculator is in degree mode, right? So cosine inverse of 0.6402 equals, let's round that to the nearest whole number, so 50 degrees. So A equals 50 degrees, and that's how you get it, okay? Looking at another example here, right? So we're going to try and label our triangle. Let's label angle theta as angle A. 2.9 across from it is lowercase a. And then you choose, I can make 2.3b and 1.7c. And then label the angles across from them appropriately. So across from 2.3 will be angle B, and across from the 1.7 will be angle C. Okay, and again, we're finding angle A. So we'll write the formula, cosine of angle A. And if you forgot the formula, it's up here, right? B squared plus C squared minus A squared. So B squared plus C squared minus A squared over 2B times C, 2 times B times C. And then plugging in the numbers we are given, then we can just, it's simply a matter of plugging and chugging, right? Just work out the mechanics of following this formula. So B squared is going to be 2.3 squared plus C squared, which is 1.7 squared, minus A squared, so minus 2.9 squared, all divided by 2 times B, which is 2.3, times C, which is 1.7. Okay, And so take a calculator and calculate all that out. So if we do the top, 2.3 squared plus 1.7 squared minus 2.9 squared, we get the top is going to become negative 0.23. And negative numbers can sometimes come from this. And then on the bottom, we have 2 times 2.3 times 1.7, and that's 7.82. Okay, so cosine of A equals that. And so if I simplify that, I'm going to write negative 0.23 divided by 7.82. And for 4 decimal places, we're going to have a number 0.0294. And that's cosine of A. Not angle A, just cosine of angle A. So if I want angle A, remember, you must do the inverse. So the inverse cosine of negative 0.0294. And remember what we said about negative numbers, right? What happens if cosine is a negative number? What is your angle in that case, right? So your angle is going to be obtuse, slightly obtuse because it's just a small negative number here. So A is going to be 90, let's round that to 92 degrees. And so there is your answer for angle A. So again, you're going to be responsible for trying the U-try problems, and we'll take those up in class when we return, and I see you again. And then I'm going to do one more example. Example 3, solving triangles. Remember what the meaning of the word solve, right? Find all unknown angles, unknown sides. So we're going to draw and label a diagram of a triangle called SUV, letters S, U, and V, with angle U being 125, side S being 31, and side V being 24. Okay, so draw a triangle that looks obtuse because you have to have a 125-degree angle. Okay, and so there's my triangle. And that 125-degree angle's angle U. Okay, so across from it is side U, which we don't know the value of. But we do know one side is 31. So I'll label this one down here, 31, that's S. And the other side is V, which is 24. Okay, and then across from S, I'm going to write angle S. And then across from V, I'm going to write angle V. So now we have a triangle with a side, another side, and the angle between them, 30, 24, 31, and the angle 125 between them. We can use the cosine law. Okay, not the ratio, but the law. Okay, it's not SOHCAHTOA, it's cosine law. So solve for triangle SUV. Now, if it helps, you can relabel this ABC. Okay, but I can also use the cosine law to find things like side U. Okay, so U squared equals the sum of the squares of the other two sides. So let me write the formula first, actually. So let's do that. V squared plus S squared minus 2 times V times S times the cosine of angle U. Okay, so just think of it like this. It's the sum of the squares of the other two sides, like the Pythagorean theorem, 24 squared plus 31 squared. But then you have to subtract 2 times those sides, 24 times 31, times the cosine of that angle you have between them, 125. Okay, so you can remember it like that, and that might help if you didn't have letters A, B, and C. Okay, and then you take that, everything on the right side, and you've got to calculate that. So we're going to do 24 squared plus 31 squared. Okay, that gives you 1537. And then if I do 2 times 24 times 31 times cosine of 125, making sure you're still in degree mode, okay, you're going to get an answer of, so it's minus, and that answer is going to be negative 853.48. Make sure you have double negatives here, right? So you have this minus sign come down, but this calculation gives you a negative number as well. So be careful with that. Okay, and so 1537, take away the negative, gives you plus, so plus 853.48, and we get 2,390.48, and that's equal to U squared. And if I want U, remember you have to take the square root of that, and the square root of that number is going to be 48. I'll round it to 1 decimal, 48.9. And if we have units, we'll put in some units, and the units are in meters. Okay, so there's side U. Are we done yet? Not quite. Remember, it's solving the triangle. What is also missing? We're missing angle S, and we're missing angle V. So we need two angles here. Now we know what the third. So we know all three sides, right? So the third side we found was 48.9. Okay. Now, if I could find one of these angles, S or V, then I can use the 180 rule to find the third one. Okay. So let's look at finding angle S. Now, once you do the cosine law once, you have enough information in the triangle to use sine law to finish it. You don't need to use cosine law again. You can use sine law, where I have a sine instead of cosine, sine of angle S over side S equals, right? So if we're looking for side S, that's the question. Angle S, that's the question. I have side S, and then I'm going to use the other angle I'm given, 125, with the u that I calculated, 48.9, right? So sine of S over S equals sine of u over u. That's the sine law. Just S, pairs of S and pairs of u equal to each other. I'm finding an angle, so I'm putting a sine on top, just like we did before. Okay, so sine of angle S over side S, which we said in our diagram, is 31. Okay, and that's equal to sine of u, which we calculated as, which is given as 125, divided by the side length of u, which we calculated as 48.9. And then we solve for sine of S. Remember how to do this? We multiply both sides by 31. So 31's cancel on the left. I'm left with sine S equals 31 times sine of 125 over 48.9. Okay, so you take your calculator again, and you calculate that right side. So sine 31 times sine of 125, and you divide that by 48.9. And if you do it correctly, you should get an answer of we'll do four decimals again, 5193. And that's sine of S. And remember what to do to get the angle S? You take the inverse, sine inverse of 0.5193. Okay, and that's going to be 30. Let's round that to 31 degrees. So there's the one angle. And if I want to find the final angle, use the 180-degree sum rule, which says that u plus v plus s equals 180. So what's missing? We're missing, well, we have S for 31 degrees, right? So now we can put that in. That's 31 degrees. We're missing angle V, okay? So angle V is going to be 180, take away the 31 degrees for S, and take away the 125 degrees for angle U. And that gives us angle V, right? So then we do 180 minus 31 minus 125, and that's 24 degrees. Okay, and so that's angle V, and that's the third piece. And now we have everything in our triangle solved. Put that in there, 24 degrees, everything in the triangle solved. We have all three sides at all three angles. Okay, so I want you to try with the you try question, and then we'll come back together in the class after. Take it up. All right, that's it. That ends this video.